Yeah, we're on 16 already. And it's so true. A journey starts with the first step and then it proceeds to the second. And before you know it, you're at the end of your journey. Now, we're just beginning. We're at 16 and we have to get to like 139 plus the appendices. And the journey is going to get, more steep over time. And what do I mean by that? It's going to be an uphill battle in some of these sections. So again, the structure, pretty simple. What do you have? Well, you have this is materials for this exercise set, which is exercise 16. It's basically a reading. You read the contents. After you read the contents, make sure you understand the examples that are presented to you. And then it's just busy exercising to see if you understand what's been presented to you. All right? Again, if you need to reach out to me, my email address is Bannon. That's B as in boy, the @ symbol, NNON.US. All right, let's start scrolling through. And again, you should get familiar with what we're doing over here. And the bottom line is it looks like it started off as factor, factor, factor. Someone says, why is there so many factorization problems? Well, the bottom line is algebra has a lot to do with factoring, and the factoring can get incredibly difficult. I'm not saying it's not going to get difficult. Some of the problems later on, they're really going to be tough to follow. All right, I got to tell you in the beginning, though, trial and error does work really nicely. And they're still talking about the AC rule. Although they may not say the AC rule, they're still talking about it. So my question over here is, when they give me things over here, probably they've got patterns for me to look at. And one of the patterns I want to point out that might be useful for you is the pattern of perfect cubes. I'll point out this right over here. And these are really nice, simple patterns. Now, someone can say, I don't know if that's true, if that's a simple pattern. You could multiply that out and see that pattern. What do I notice about it? I want to point out what I'm noticing over here. Look at the A cubed, A squared, A, no A's. Then it's B cubed, B squared, B, no B's. I hope you get the impression of what we're doing over here. This one, it's really the same thing, but there's a difference now. I hope you notice that the signs are alternating. But they sure are remarkably similar. The coefficient, 1, 3, 3, 1. There's 4 terms. All right? This is what's known as a binomial expansion. Let me get my eraser out, indicating these are going to be really important patterns now and in the future. All right? So someone's going to say, if that's true, what are you going to be doing with these problems over here? I'm going to be looking at them, and I'm going to be looking around for pattern. All right? Now, someone's going to say, I just like to play with it to see if I can see something else in the problem. And I'm not saying you can't. I'm not saying you can't. Like if I were looking at this one over here, the first thing I would probably do, if I were looking at it, and someone says, what do you mean looking at it? And they said factor it. The first thing I would probably do is just simply look for something. And again, I'm not saying you're going to be successful at it, but I'd say, there's 4 terms. Let me see if I can group it. So I'd look at the first thing and I'd probably say, 4a squared. And what do you get next? Well, 4 times what would give you 8, 2, and you need an A. And 4 times what would give you 36, 9. And then what would you get? Well, then you get, the A squared is covered, you get B squared. Plus, I'm going to say 27, B4. And then what would you get? Well, let's take a look. You would get 2A. Let me see if that's true. Yeah, that's true. Minus, and I said 27, right? Minus B squared. That's not success. I'm looking at it, I don't see anything that's common between those 2 terms now. So I would say, that's a dead end. Now, what someone might say now is, well, what if you rearrange the terms? Would it be helpful? I'm not saying it wouldn't be helpful, but I'm looking for something else. So someone says, what are you looking for? And I want to point out, I'm going to start writing down, what I believe I see in the problem. And someone says, I just don't see what you're seeing. They're pointing it out to me. They say I'm probably seeing something like this here. Let me get that outline for you. You're probably seeing this guy. Now, someone says, why you think you're seeing that guy here? I'm kind of looking at it, and I notice there's, and I'll underline it for you. I notice there's 1, 2, 3, 4 terms, and the signs are alternating. All right? So I'm going to kind of maybe it's going to work out for me, but don't believe it will until you try. So I'm thinking that maybe that the A in the problem, again, this would be the A in the problem, would be 2, when I say the A, it's the A cubed in the problem, the first term. It looks like 2A, right? And I want to look at the last guy, and I'm wondering what the B in the problem would be. And I'm looking at it, it looks like 3B squared to me. Because if you cube that, you'd get 27B6. So I'm going to write this down for you. I'm going to write down, I think this is this pattern over here. 2A minus 3B squared cubed. I'm going to go through this now, and I'm going to write down every single thing in the problem. What do you get over here? You would get A cubed. Well, this is A, right, the big A. When I say that, it's a little confusing with the big A, little a. That would give me 2 cubed, which is 8, A cubed. Then what would you see? You would see, and again, I'm looking at the pattern, you would see minus 3 times A squared. When I say A squared, I'm talking about the big A. That's 4A squared times the B. What's the B? 3B squared. Then I'm going to the next guy. What's the next guy going to be? Plus 3. And again, I'm just seeing if it works. 3 times A. What's A? When I say A, the big A. I keep saying that, right? It's going to be 2A. And then what would I be at B squared? What's B squared? 9B4. And then minus B cubed. What's minus B cubed? Well, that's not so bad. It's 27B6. Do I get what I want? I got this. I got this. Let me see if I get this guy over here. And again, I'm looking at this. Did I get it? Well, 3 times 4 is 12. 12 times 3 is 36. I got that part. A squared, B squared. I got it. Let's see the next one, see if it works. 3 times 2 is 6, and 6 times 9 is 54. I'm seeing that. And what do I see? AB4. It worked out beautifully. So this is the factorization. That's the factorization, all right? Now, if you look at the key, they go through that, and I'm seeing that right over here. Let's keep going. Geez, there's no other examples. So here's the deal. They want you to exercise now. So the problem is, I bet this has something to do with these patterns, right? A plus B cubed, and something to do with A minus B cubed. Let me write them down again for you. A squared, I'm sorry, I misspoke. A cubed plus 3A squared B plus 3AB squared plus B cubed. This one over here is going to be A cubed minus 3A squared B plus 3AB squared minus B cubed. All right, now granted, this is chicken scratch. I do want to point out what we're really talking about. Let me get my eraser out, and I'll just outline these again. These need to be known. They're simple patterns, and these patterns are going to pop up again and again and again. They're nice, simple patterns. Make sure you know that when you're doing this problem set, these are the two things. They need to be recognized. So the bottom line is, maybe you want to have your chicken scratch down like I had over here, but every single problem that follows here is going to be of that nature. All right? Every single one. Somebody might say, why are there so many problems over here? Well, practice. Practice is going to make you perfect at this. There's no doubt about it. Practice will make you perfect. Just again, related Sage code. What is Sage? It's a computer. Whoops, let me shrink it down a little bit for you. It's a computer algebra system, or a CAS. We typically just say CAS. It's free. It's available on the internet. You go to this website over here, and these are clickable if you have the PDF. You could download the application or use the web-based application. Reset gives you a clean sheet of paper, defining variables, expanding, factoring, yada, yada, yada. You'll learn by trying, by the way, and you'll learn by typing as well. Thank you for paying attention. Again, if you need to reach out to me, my email address is Bannon. That's B as in boy, @NNON.US, all right? Only if you need. Don't reach out if you don't need to reach out to me, all right? I may not be able to answer all the emails I get, but I'll try my best to answer emails that, particularly if you're pointing out any errors or something that you think are in the notes. All right, thank you for paying attention, though. You do want to move forward, though, but at your own pace. Do not think this is a race to the end. There is no end in mathematics. Enjoy the journey.